Good afternoon, everybody. My name is Dr. Biplab Sinhamahapatra. I am a faculty of School of Applied Science and Humanities. I am going to teach you today probability and statistics. Probability is a tool to solve the problem of statistics. Basically, when everything is certain, we don't need anything to study. Formula is available, and you can always find the respected values which one you need to solve the problem. But the thing is that almost everything is uncertain. And do you know what is the information value? So information value of anything, if we want to write here, then it is equals to information value equals to n log n, where n is the probability of any event. So you can see that if it is certain event, then you can get the probability is equals to 1, as usual the information value equals to 0. So the sun rises in the east is an information, but its information value is equals to 0. So only thing which is unpredictable, there you will use the statistics as a tool to predict the things. So if I go to the basic of probability, it starts in the 17th century when if I say the father, if you are saying father of statistics, no one is there. Basically, it is started from the gambling. That time gambling was a very popular game among the kings, among its surroundings. So you can see that this is a gambling casino type things. It is here. So if I go to the next slide. Okay. This is introduction of probability. You consider that it is the foundation of statistical theory, and there are several mathematicians have contributed in this thing. Their names are B. Pascal, Bernoulli, Dreamweaver, Bayes. These are the mathematicians who have contributed in the probability portion. If you want to know the probability, you have to know two things. One is permutation, another is combination. So basic permutation combination formulas are available, and I think you are capable of that. So we can proceed beyond the concept of permutation and combination. So probability is used in statistics as a chances of occurrence of an event among a large number of possibilities. So let's say that basically if you want to measure the probability, let you know that tossing of a coin. So you know that tossing of a coin, if I want to find the probability of head, it is equals to 0.5, but who says that? So for that reason, you need to know what is a fair coin, it is unbiased or not. These things you have to test it. So in that case, if you want to find the probability of a head when you are tossing a coin, what you need to do, you have to toss the coin a large number of times, and then if you are taking the number of trial, which is tossing of the coin, is tends to infinity, then you will get the probability of head equals to 0.5. This is the 1650 the society in French. As you can remember, this time France was very fastly growing compared to the other countries in Europe. So the games of chances are also very much played in that society, and it is not like that. If you are thinking that this is a bad thing, you are playing the gambling, not like that. In that time, that is a game was played among the very rich people, very cultured people of that time. Okay, these are the three mathematicians I am introduced here. One is James Bernoulli. As you all know that Abraham D. Weaver, as basically you can remember from cos theta plus sin theta whole to the power n. But he is also known for discovering the normal distribution. That's the very more important distribution in statistics. And another name is Simon Laplace. So now we will discuss the basic terminologies of probability. whenever you need to know any new things, you have to know some term of related to that topic. So it starts with the random experiment. So what is a random experiment? Random experiment basically, let you take an example of tossing a coin. Tossing a coin means you will get head or tail. You know that either you will get head or you will get tail. But if I toss at present, at now, you cannot tell with certainty, with 100% surety that heads will turn. So these type of experiment are called random experiment. So whenever we are discussing any experiment, basically what is an experiment? Experiment is an act which can be repeated in identical conditions. So that is an experiment. Random experiment means you know the results, but you cannot tell with certainty that this will happen in our next trial. That is called a random experiment. So sample space is the set, or you can call universal set in terms of random experiment. It's contain all the outcomes. Outcomes mean results. When you are tossing a coin, the sample space will contain head and tail. Event basically is a subset of sample space. So if you are tossing a coin, head and tail you are getting, then head is a subset of the total sample space. Tail also that. So there are two types of event you can get. One is called simple event, another is called composite event. Depending on that, if it is, we are always discussing tossing of a coin. If we go for another one, that you are throwing a dice, then you will get the number 1, 2, 3, 4, 5 and 6. Okay, and if we call that 1, 2, 3 is a set you want to get, then these number set contain 3 simple points. Those are 1, 2 and 3, and it is called a composite event. And next one, null or impossible event. You know it's not give you no outcome. If you are tossing a coin, you want 100 on that. How could you get this? There are only 2 things may happen, head or tail. It never comes out 100, so you will get it is nothing in the sample space, and you will get it is a null or impossible event. Elementary event which we have already discussed. Simple event, composite event means contain more than one elementary event. Sure or certain event is basically it's contain all the sample point, means contain the sample space basically, and it will definitely always happen. That's why its name is sure or certain. Next, exhaustive event, favorable event and mutually exclusive. Exhaustive event is something like that. Sometimes we say in the evening that we are exhausted, means 100% energy is already we have done, nothing energy left in my body. We call it we are exhausted. So if 2 or more events you are getting and you are making a sum of them, sum in terms of set theory is union, you will get the sample space, the total over, then they are called exhaustive event. Exclusive, if you are taking an intersection between them, and you will get nothing on that. As for example, if you are taking 1, 2, 3 is an event of A, and 3, 4, 6 as another event B. If you make a union of them, you will get the whole sample space of throwing of a dice. And if you are making an intersection between them, then you will get as a 5, nothing is there. Those are called exclusive event. Favorable event means which one you want to happen. That is your favorable. Means if you are playing Ludo. Okay. If you are playing Ludo, then you know that you always want a 6. Not always. Sometimes you always. Sometimes it may be wrong. In that case, 6 is your favor. Okay. Sometimes if you get 1, then you can cut off another, maybe your opposite partner. That one, then that will be called your favorable. Equally likely or equiprobable event is something like that where everyone having the same probability to be happy, everyone having the same chances. Tossing up a coin means both head and tail having the same probability to be happen, then it is called equiprobable. Complementary event means if you are taking one event and you are subtracting that event from the sample space, then you will get complementary event. As for example, if you are taking the even points when you are throwing a dice, then you know that the other odd numbers you will get if you subtract this from the sample space, then there is a called complementary event. Independent is something different compared to others. Independent events, we call two independent events mathematically, is probability of A intersection B. If I can write here, it will be proved, but this is equals to P of A into P of B. But look at this. When both of them having no connection between them, then we call they are independent. Okay, you can see diagram of sample space. This is whole is the called sample space, and these are the points, sample points you have. If you take a single one, then it is called simple event. If you this one, look at this color shows you 1, 2, 3, 4, 5 points are there. So that's why it is called an event, which is definitely it is a composite event. Basic concept, I think you know, when proper in intersection, union, complementary, disjoint, these things are very easy. I think you all know that. This is the examples of this set operation. Now there are some rules in basic set theory. I think you this is also know that commutative law, associative law, distributive laws. This is a Venn diagram which can give you the intersection point. This is the common of A and B, that's why the intersection. If you are taking both A and B, means when you are taking at least one, then what will you get? That A, B, and since when you are taking A, B, this portion, this common portion are taking twice, so you have to subtract one times A intersection. That's the thing you have to do when you are finding A union. So we are going for the next one, rule number 1. As you all know that probability is always lies between 0 to 1. If someone says that, let me give an example regarding this one. Sometimes we have seen in a newspaper or in news that a player is telling that I will give 200% in my next match. So yeah, so I think he is lying. In that case, basically whatever he can give, that is his 100%. So how can he give in next match 200%? It's not possible. That's when you can say, to be correct, that in previous match I have given 50%, so I will give in next match 200%. So it will be 100% next. So basically, on that case, possibility of any event lies between 0 to 1, because of 0 means nothing, impossible event, and 1 means silent. Now, let me give an example of this one, that for the previous rule, if we throw a dice, look at this, if you rolling of 6 points are there, 1, 2, 3, 4, 5 and 6, and if you want to find probability of rolling 8, so how can you get 8? The point is 6 last one, so probability is 0, and any number between 1 and 6, definitely you will always win the game. 1 and 6 between any number you will definitely get. Obviously both are inclusive. Next one, the sum of all the probabilities for possible event is equals to 1. So if we go for this one, look at this. This is an example. 52 card deck. So as you all know, there are 4 strips are there, 2 colors, red and black. And in black color, you know, clubs and spade, and in red color, diamond and hearts. These are the possible cases are there. And if you are finding the probability of red, then there are 13 cards from hearts and 13 cards from diamond. So it is 26 is your favorable point, and 52 is the total number. Plus black, 13 spades and 13 clubs. So it's also give you 26 divided by 52, and it is equals to 1. Next, complementary, anything if you want to find the complement of an event, then it is equals to 1 minus of that probability of A. P of A complement equals to 1 minus P of A. And obviously the second part is also true. Now, look at this. Acha, for this one, this is an example of rain. So let me tell you, you all have seen the weather report in Google, but you never can see that the probability of rain is equals to 100%, or probability of no rain is equals to 0. It's never happened in that case, because this is an basically you cannot predict that much correctly that it will be happen with probability 0 or probability. So if someone says that probability of rain equals to 0.3, then probability of no rain, not rain, is equals to 0.7. So these are complementary event, since the sum of the probability is equals to 1 here. Now we will go for the addition rule. Let me tell you what is the addition rule. Let you are coming from your home to your college by two different ways. You can choose 3 different buses are coming from your home to college, and 2 different train routes are also there. You can choose from that. Then you can come to college from your home by 5 different ways, 3 from the bus and 2 from the train. So when a job or a work can be done by in total ways, I mean starting to ending, you can done by a way, then it will be added. And if it is divided into parts, then it will be multiplied, which can be go for, this is the addition rule for 2 events, and this is for 3 events. And obviously there is nothing common between A and B. That's why it is not subtracted, as you have seen previously from the Venn diagram. Now example of this one, I am coming to the product rule next. So look at this here. Okay, in a deck of cards there are 4 kings and 4 ace. So probability of king is equals to 4 divided by 52 is coming 1 by 13. Also for ace equals to 1 by 13, same way. So if it is king or ace, then look at this. No king or ace and no ace are king. So that's why there is nothing common between them. So we have not to subtracted the intersection between king and ace. That's why the probabilities are directly added. Otherwise we have to subtract the common. Now this is the second, when 2 events are not mutually exclusive. Not mutually exclusive means if they are mutually exclusive, then you will get the probability as equals to let me write that probability of A union B equals to P of A plus P of A when they are exclusive. Why? Because if 2 exclusive events are there, then probability of A intersection B equals to 0. Why? Because they have nothing in common. So if they have the common thing, then you can remember from the Venn diagram, it is obviously that A union B equals to P of A plus P of B minus P of A intersection B. Now this is a problem. Calculate the probability that on tossing a pair of unbiased die means 2 dice are there, the sum of the digits is equals to 7. So let me tell you that if you are throwing 2 dice, then the number of sample points you will get 6 to the power 2 equals to total 36 sample points. How? This is called the face to the power number. When you are tossing a coin, then number of face are head and tail. 2 is the face number, and if you are throwing 3 coins, then you will get total 8 sample points. When you are throwing a dice, then it has 6 faces, and you are throwing 2 dice. So this is face to the power number, you are getting 36 total number. Now 7 is the number as a sum of 2 digits appearing for the 2 dice. So 7 you can get by either you can get by 6 and 1, or 1 and 6, or you can get 5, 2, or 2, 5, 4, 3, or 3, 4. These are the sample points which give you the sum of the digits appear on the 2 dice is equals to 7. So total favorable points, sample points, you are getting 1, 2, 3, 4, 5, 6. And number of sample points earlier mentioned 6 to the power square, so you are getting 1 by 6 as the probability of the first answer. Now, rest of the questions are there, you can solve it. If I am going to solve all of them, then it will end up my class by today. So we will go for the next one and it will be your homework, you can easily solve it. Now, this is the second rule, which one I am already earlier started, that multiplication. Multiplication rule always happens when this is the way your home and you want to go to your college by this. So, up to this portion you have to go by bus, then you have to train. Let there are 3 available alternative of buses and 2 alternative for train. Then how many ways you can go from your home to college? This, look at this, 3 into 2. How? 3 into 2 equals to 6 is the answer. How? Look at this. Let you fix a train. One train you will choose. You are starting from a bus. So one bus, one train, one bus, the same train, one bus, another is the same train. So 3 way, and another it will be happen for the second train. So this is called the multiplication. So and this is called the probability of A intersection B as the probability of A and B, and obviously this will be probability of A intersection B always less than probability of A in. This will be equal when the A and B are both equal, otherwise it is not never be equal. Next, look at this independent events. Independent events, I earlier mentioned this one, that this is the probability of A intersection B equals to P of A into P of B. But why this is happening? Look at this. Someone is trying to pass an exam and the probability of that one equals to 0.7. Now another one person is trying to pass the exam and its probability of passing the exam equals to 0.6. So both of them will pass the exam because no one is helping the other, no one is not connected to the other. In that case, the probability will be definitely decreased. It depends on the other. So in that case, you will get the probability of A intersection B equals to 0.7 into 0.6. That is equals to 0.42, which is less than both of the probabilities, 0.7 and 0.6. And this is same one for 3 events. Next one, look at this, another example, ace of diamond. What is the probability that you will randomly pull the ace of diamond from a standard 52 card deck? So diamond unit, also you would need the ace of the diamond. So how many aces were there? Previously I said that there are 4 aces. And how many diamonds are there? 13 diamonds you have. So it's diamond as well as it is a S. And both are, look at this, probability of S into probability of diamond, and you will get the probability of diamond S. This is the cost. So let us start the conditional probability. First of all, let me tell you, conditional probability is something like that when you are having a condition, already you know something and you are finding the probability. And if we give an example of ball, look at this, 5 white ball are there, 7 red ball are there, and 2 white and 3 red balls are there. Now, one ball is transferred from the box 1 to box 2, one ball it is, no, we don't know the color. If someone say that you are finding a probability of white ball from the second box, probability of white ball from the second box, no other information. Then there are 2 white ball in the second and total ball is equals to 2 plus 3 plus 5. This is the problem. Simple case. Now if someone says that one white ball is transferred from box 1 to box 2, then this information you will write like this way, that you are drawing a white ball from the box 2 when one white ball is transferred. This is the known information you have. So it will not be same as drawing a white ball from the second, since you have an information that a white ball is already transferred from box 1. This is basically box 1 and this is box 2. So it will be probability is equals to one ball will be increased here, so total ball is equals to now 3, that is the white, and total ball will be also increased as 5 plus 1 equals to 6. This is the probability. Now we go to the theory here. Look at this. When A given B is there, B is already happened. So from B, how many portion of A is there? That's why this is the intersection in the numerator, which is your favorable, and total B is there. So the thing is that you need to consider that this is the thing. Let me write that this is not sample space. So conditional probability, when you are writing the denominator which previously contained the sample space, it is not here. So B given A are also same. Only if it is A given B, then B will be in denominator, and B given A will be in denominator. Let we go for an example. Look at this. In a large class, the probability of randomly selected a woman is equals to 0.6. So if you are selecting a woman, probability of W for woman is equals to 0.6. The probability of randomly selecting a student who is a woman, then it is a student. Not all women are student, and who earn an A grade. Also they have to earn an A grade. Then this probability equals to 0.2. If you randomly selected a student who is a woman, what is the probability that she earn an A grade? So look at this. Here it is already known that. So A, if we are considering an event, earning an A grade, and B, being a woman. Look at the solution. Then we want to know the probability of earning A grade given that the student is a woman or female. So you are finding the probability of A, which is earning the A grade when it is a female. Now look at this. This is the probabilities are given to you that it is a female and earning an A grade, which is 0.2, and probability of B, which is only female, is 0.6. So you will use the formula and you will get the probability. So, and this is simple thing that if you want to transfer any probability to percentage, you have to multiply by 100. Now another example if you want to check. Look at this probability. There are 52 card deck. What is the probability that a randomly selected card is a club, given that it is a black card? So as you can know that how many black cards are there? Total card is 52, red card half of them, and black card is equals to 26. Now if you are finding that the selected card is black card, so look at this. Probability of club is equals to 1/4. 4 suits are there, and black is equals to 0.5. Now club and black. So 13 cards are there, so adding by 52. So club given the black, when you look at this, this is not all the cards here. It is only the black cards here. So that's why it is the half of the cases you have, means it is 26. And club, obviously if it is club, then it will be black. So there are 13 are there. That's why you are getting this is equals to 0.5. So one thing you need to notice that it will not contain the sample space in denominator when you are finding the probability by this conditional event. Last one for today, total probability. First of all, let me know what is total probability. Look at this. 3 red, 4 white balls in our first box. Second box is another there. So it is 4 red balls are there and 3 white balls are there. If I am writing R1, then you are drawing a ball, red ball from the first box, and if I am writing R2, then it is you are drawing a red ball from the second box. Obviously, you can understand why W1 and W2. Now look at this. If you are simply finding the probability of W2, no other information, then it is equals to 3/7. 3 the total number of white ball and total ball is equals to 7. Now, one ball is transferred from box 1 to box 2. One ball is transferred. It is not mentioned which color ball is there. And now you are finding probability of W2 with this information. Then you have to consider it may transfer a red ball, then you are drawing a white ball from the second box, or another condition is there, maybe one red ball is transferred, then you are drawing the white ball. Both cases you need to consider since you don't know which ball is transferred. And don't argue with a realistic situation that how could it be two ball can be transferred in a single situation. Not like that. It is either this one happen or this one happen. So that's why we'll make a plus of it. So you can write that a white ball is transferred from box 1 to box 2. Then you are drawing a white ball from the second box with the information that a white ball is transferred plus probability of R1 when a red ball is transferred into you are drawing a white ball from the second box with the information that a red ball is transferred. So then you can easily find the probability. So it is equals to 4 by 7. Now one white ball will be increased here. So total ball is equals to white ball is 4, 8 is the total ball plus one red ball is transferred. So 3 by 7 into 3 by 8. So this is the total probability. So if I want to accumulate this one, if there are the problem you have, you can solve it by your own cases. Next, in our next class, when we will finish this, another part we have left one which are called Bayes theorem. Then we will go for a shortcut method to remember all these possible formula for probability evaluation. And don't think you can solve all the questions. Not like that. Even I cannot solve. Even it is very hard to solve the question from this chapter, Fundamentals of Probability. So at least if you can solve the 90% of the question, then it's good, quite good. Thank you everyone for listening.